Okay. Hello, everyone. We are live here. I'm Jacob. I'm a software engineer at Blazity. I'm here today with my friend Łukasz.
Hi, developers. My name is Łukasz. I'm also a software engineer here at Blazity. It's nice to have you here.
And today we are going to talk about core Web vitals. We will talk about which of them measures, how to check, how to check our sites, and also how we can fix it in Next.js. But before we start, make sure to download our free ebook. The link is right here in the QR, also in the description below. Also, make sure to check out our podcast episodes as well as our optimization tips videos. So yeah, I think we can jump in.
Okay, great. So we are going to talk about the core web vitals, right, Jacob?
Yeah, exactly.
So first, maybe a short introduction of what it is. Speaking very roughly, it's a set of metrics used to, measure like page speed, interaction speed. It consists of three things: CLS, as you already see on the screen, then INP, and LCP. And
Okay.
yes, we'll talk about every single one of them. We'll tell you how to fix them if they are broken and what to avoid to not break them. So we'll start with CLS. Jacob, if you could explain what this is.
Yeah, of course. CLS actually measures a website visual stability, and it tracks any unexpected content shifts during loading. It can be breaks by, for example, image without specified dimensions, and also some dynamic injected content, such alerts or lazy loaded sections without loading skeleton. So if you have any question about any of them, just ask in a chat. And we are going to the second one is ENP. And Łukasz, what is ENP?
Okay, it's interaction to next paint. It talks about the interactivity part of the page. So this is, for example, in the advanced terms, technical terms, it's the time between the user interaction and actually painting the next frame. So this is, for example, when we have buttons, links, or something like that, that when the users click on, they expect an action to happen, right? But INP measures the time between, the click and the feedback. So it gets broken by things like heavy work on main thread. So let's say parsing huge JSONs, maybe fetching something synchronously, working with file system. This is all these things that are synchronous and the web page.
Okay.
Yes, and we have you have a question, Jacob?
Yeah, so just wanted to make sure that I understand it correctly. So it actually measures, for example, you have the button, which said display some dialog, for example. So it actually measures how long it takes after the click and when the dialog actually appears, right?
Yes, that is correct. That is exactly what INP is. And it's always like the worst measure, right? So, for example, some links are going great. They are reacting to every, user interaction. But we have this one button that destroys everything.
Okay. Yeah, and also the user device could also have some impact for this
Yes.
measure. So last but not least,
the
we
LCP
have,
thing. Yeah, Jacob. So what is it?
So yeah, LCP actually measures how long it takes for the largest content element visible in the viewport to become fully loaded and visible to the user. So we can think like your hero banner with the image or long text. So every unoptimized image and, for example, unoptimized font loading could have an impact for LCP. And yeah, we always need to locate our LCP, our largest contentful paint. So I think we get it covered, and we can go.
Yeah, I think we explained like this was just the introduction, and now we can talk about what everything is on a real demo.
So yeah, let's jump in.
Great. Yes, so we are here on the demo page. This is a simple landing page that has a huge hero banner, as you already see. So yeah, we can think about this as the largest contentful paint already. Then we have some sections, some content that is not really important. We have some buttons, some interactions on this page, and this little thing here that displays the live metrics. So maybe first, before diving into the code, we will tell you how to find the issues. We'll talk about the tools that you can use, and we'll start with Lighthouse.
Okay, sounds good. So Lighthouse is like is available in our browser DevTools. So it actually measures like in our local browser. So let's maybe run the test for
Yes,
our.
we'll run a test on desktop, only performance, because this is what we are focusing on today. So yeah, the Lighthouse loads our page and displays the performance score.
Yeah, the
So
performance
we
is pretty
see
bad.
that this is bad. Yep. So we see that we have LCP sitting at the red range, 10 seconds. What is this? This is huge number.
Yeah, and also CLS is pretty bad.
Yes.
As well as other metrics that you can see here, other than
The core
core
web
web
vitals.
vitals. Yep.
Yes.
So yeah, it actually measures it in our browser. So our device, when you have the good laptop, it may have an impact for it. So can we somehow simulate it? Check it on other devices?
Yes. So what we can do first, while we are on the DevTools, we have this also performance tab, not only Lighthouse, where we can do some CPU throttling, maybe network throttling. We see the local metrics here. We have the INP here that we are talking about today also. So maybe I will show you which button is the worst one here on this page. And we ran some tests before, and our audit has shown that this button here with the discount, this is the enemy of the performance. So when we click it, we have to wait, okay, 2 seconds almost. That is a huge number. So for these 2 seconds, the user couldn't do anything, right? Like interact with any other element on the page.
Yeah, it actually blocks our whole UI, and the browser waits for it to show, so it's not like handle any events. Okay, that's great that we can like easily check these metrics in our browser. But we have prepared something else also.
Yes, because this is everything is happening on your local device, right? So you have to test on other devices. You have to test on simulators, maybe, and also the most important part is to test the real user data, right? So we'll talk about it one by one. We'll start with the test on Webpage test. Where we already run the core web vitals test here. So Jacob, you see the numbers are not looking great.
Pretty bad, and also you can see the screens for every single metric, and you can locate, for example, in this case, your LCP.
Yes, that's correct.
And it says how long it takes.
We see that the image is rightfully the largest contentful paint here. So this is what we will be looking for in the code, right?
Yeah, in the first place we should check it.
Yes.
We got some diagrams here. How long
some
it takes
more
to
data
load
for debugging. I believe this is the image that is being loaded, and you see this is huge, even for my laptop screen. And like I'm not even talking about the small mobile screen because it's too big.
Yeah, that's why it takes like almost 10 seconds to load this image. Okay, but this is still simulated data. So we have Lighthouse to test it on our local machine. As you can see here, the CLS also.
Yep.
You can see how it moves on the frame.
Yeah, I believe we have a problem here. We don't see the alert being shown, but this is where the alerts are loaded lazily, and that's a big problem because the layout shifts.
Yes, exactly. But we can also see that there's something wrong with it because yeah.
Actually, maybe we can show it right now live. So we'll go into a mobile device and just reload. So we'll see the layout shift. You see
Okay.
this alert
I
here
see.
is the problem.
Yeah, it's lazy
So
load. So
yes. So what else, Jacob? We tested locally. We tested on the simulator.
yes, exactly. So we have the simulated. We have our own local machine. But what about our real users' data?
Okay, we have this thing.
We
We
somehow
have a lot of tools to measure the real data and to get the real insights. But I will start with page speed insights that should provide a real user's data from the field.
okay.
This is also something we already have in the performance tab if we configure everything correctly. And the rest is also a simulated device, and we get a normal, like something comparable to Lighthouse.
Okay.
This report, yes,
And we also have some suggestions for each
that's true.
how we can possibly improve it.
Okay, so we already see that there is blocking requests. There are font problems, legacy, of course, JavaScript,
Layout
LCP,
shift.
request discovery, layout shifts. Yeah, we will look at that in a second. But we also want to show the real user data. And for that, we used Vercel's speed insights, right?
Okay. Yes. As you can see here, we have the real user. So wherever someone enter our page, it actually measures it and save it here. And we can see that it's also bad. So we have some red, we have some yellow for CLS, ENP, and
Yes.
first contentful paint. In this case,
So
LCP is pretty good, but yeah, if we probably change it to mobile,
yeah,
it
we
should
see
be
the LCP.
good.
Okay, it's loading, I guess. But it's getting worse with the new data that we get from today. We are having red scores at INP, of course, and then layout shift is also sitting at 0.14. So yeah, that's not good. And the score is 16, and this is only for the desktop version. So
Okay.
Jacob, I'm gonna show
Great.
you the mobile version, but
Yeah, let's
prepare
change it.
yourself. This is a huge
Yeah, there we
number.
go. The LCP is
Oh
almost 10
my god.
seconds. Our really experienced score is 40. This is not an
bad.
experience, I would say.
Yeah, this is yeah.
Okay, so I
So
think
LCP at 10 seconds, terrible. INP, of course, sitting at 1.7. It's very bad. Maybe the layout shifts are better because we don't see both alerts
yeah,
being
on the
stripped.
mobile screen, yeah, we can
Yes,
only see the one. So it only
but this is
measures one.
something that has to be fixed.
Okay, so I think we can start trying to fix it. I think we can first focus on LCP because this is our
Okay.
main problem here. So as you
So
said, we
we have
would
already,
look at the image here. First, we are using the EMG tag from HTML. We
yeah,
can change
classic
it to
mistake of beginner Next.js developers. So what we are changing this to an image component.
Image component,
Wow.
exactly.
Perfect. Not Lucid React, but next image.
Yeah, and also you should
Great.
probably use the field prop in this case because you actually
Okay, so because we have a parent element here, we can use fill, and this is gonna set the absolute stuff here. Oh, I already see some AI tips.
Okay.
how to, but we'll talk about
Maybe.
it one by one.
Yeah, one by one, exactly. Secondly, we said that the size of the image is a problem. So we should consider using sizes, like different sizes for different viewport.
Okay.
So we can actually do it with the sizes prop. So we
Okay.
can jump back to code, I think.
Maybe I will show how how only the image component already fixes some things, the size of the image, as you've said.
Okay.
So here we have the live version of the page that is having the poor performance. Let me tell you that this image is huge. It's sitting at 7,700 pixels wide.
Yeah, it's more than 8
yeah.
megabytes, right?
Yeah, almost 9 megabytes. So these are requests that every user has to make, and 9 megabytes every visit without caching, that is a bad score.
Yeah, we shouldn't even use that big image in the
Yes.
website, but yeah, we can
So
for sure fix it.
yes, but setting and using the image component from Next.js already changes the HTML structure, as you see here. Maybe I can make it a little bit bigger for you. If I could.
Yeah, would be great. Yeah, I can see it
Nice.
better. Yeah.
You already have a source set for the image. And we are already at 1.2 megabytes. What do you think about this?
That's better, of course, but we still render only 752 width of this image, so we don't need to fetch the entire image, right? So the original size of the image. So we can use the sizes prop, as I mentioned before. And yeah, you can do it actually. What cursor?
Yeah, we'll just follow the cursor AI.
Yeah, let's vibe code it.
Great.
So yeah, it actually says to Next.js that for the images with 768 pixels sizes or smaller, this image will use 80% of the viewport. We can change it actually to 50% because we actually
50 here. Okay.
Yeah, it takes half the screen.
Sorry.
In this case, I think we can stick with the 50 also, I believe. And yeah, for the larger screen, it will use the fixed value of, I think, 800 pixels. We can change it.
800. Let's do it. So this is something that you can measure, like actually, right?
Yeah, we can
something
actually
that you
check
optimize.
Yes, because the sizes prop actually works with the device sizes in Next config. You can also
we have to
here.
modify something. Okay, Next config.
We can, I would say, because actually Next.js provides us some defaults here with the device sizes. This is the breakpoints, the width breakpoints, where the Next will generate the variant of this image, but only if you are using the sizes prop. So as you can see here, it actually, and you can reload the page to make sure.
Will do. Great. So now I will check it. I'm only looking at the file size, and it's already 200 kilobytes.
Yeah, because we're actually using the smaller version of this image. Even when you change it to the mobile version, it should be even smaller, because we actually set Next.js that for the mobile it will use the 100% of the viewport. So when
25 kilobytes.
Yeah, exactly.
So I think this is already a huge improvement, right? So maybe what about a Lighthouse test? Or do we want to change something else?
We should do it. We should do the Lighthouse and check the
let's see.
CLS. In this
oh my
case.
God, this was at 62. The LCP, yes.
LCP, yeah.
And we are doing a desktop test now. Okay, let's wait for that to finish. It is already green, and we haven't done a lot of work. We still have CLS at 0.1.
But LCP is only 1 second.
Don't forget about the INP, yes. So LCP is 1 second.
Yeah, it's green. It's green now.
Very nice.
With these few little changes, I would say. But if you try to refresh the page again, you could notice that
there is a flash. Yes.
Yeah, there is a blank space before image loads. So in order to improve user experience, in this case, we can use placeholder also for this image.
Okay, let's see. So it's a placeholder with
Exactly.
blur, I guess.
Yes, but in order to use it correctly, you need to import this image statically to this file.
So here, okay, cursor is smart about that.
Cool.
We set the source to this one, and this should already do something, right?
Yes, it should generate a blur effect before the
Let's see.
image loads.
Okay,
Yeah,
nice.
that's very good. And also, if you want to learn more about the placeholders, make sure to check out my latest video in this channel, and you will learn how to do the same effect, the same blur effect for the images, for the dynamic images, third-party images, because in this case, we actually host this image in our application. So yeah, I encourage you to check it out. And now I think we can mark LCP as done, as fixed.
Okay, one more thing, because I'm thinking, okay, we have this blur, but I still see this LCP, request discovery, and we are lazy loading this image, I think. And we can, as its hero image is above default, maybe we can set the priority for this one.
Yeah, I think you're right. We can actually do it. Set the priority. And also, I believe that Lighthouse suggests to do also the priority, fetch priority.
Fetch priority, yes.
To
okay,
high,
so we'll do it also. Great, cool. Okay, so I don't know. We can do another Lighthouse test for this.
Yeah, let's check.
And we were sitting at what, 1 second before?
Yeah, 1 second. It was 1 second before. Yeah.
Great. So now
It's
when
already
we set
good,
the
but
0.7.
0.7. Okay.
This huge improvement. We were at what the simulated tests showed.
Around 10
yeah,
seconds.
Yeah, that's too big.
Yeah.
So we also see some font errors, some font insights. I don't know if you want to continue with that one or maybe stick with CLS first, for example.
Yeah, let's stick with the CLS, because I think for the fonts we could also fonts could also impact on CLS. But in this case, our main problems are these two banners, I believe, because they are
so let me refresh so you can see. Yes, they are coming it after some time and shifting the layout. So this is the problem. Okay.
So let's jump the code again.
So what can we do here? Because I think we are rendering one at the top, one in the middle. We have some delay set.
Yeah, it says some delay because we could think that this actually fetch some data, for example. So when it's loading, we could create some skeleton for it, some loading indicator for this component, in order to show the user that something is logging, that something is loading. So this is the first one. We improve user experience, and then the CLS will be better if we could have some skeleton here.
Okay, so I will set the skeleton here with H16. So this is something you can also measure just by doing this trick. So on desktop we are at what, 68 pixels. So I think 16 is enough in Tailwind.
Okay.
So we will now render this skeleton while this data is loading.
Yes, exactly.
This should already fix the layout shift, right?
Yeah, it should be visible without any testing, I guess. That there are some loading.
Yeah. We can see it for sure. It's a little bit, the contrast is too small maybe to see it, but it's here. Yep.
Yeah, we can see that it's not jumping, there is some loading indicator further, and then alert appears.
So maybe as this is local, we are.
Yeah, we could also run there.
Yes, let me refresh. I don't know why the body element here is jumping. while it shouldn't be. But okay, let's run Lighthouse.
Yeah, let's check it.
Let's see.
And you're on the desktop, right?
I am on the desktop. Yes.
Okay.
Oh, performance 100 already.
Nice.
And
Yeah,
layout
our CLS is
shift
better.
almost 0.3. Yeah, 0.28. This is much better than it was. And
Yeah, it's green.
also, I remember we had some problems with the font because it's blocky.
Exactly. It also may have an impact for CLS when we are loading our fonts. So actually, let's check how we actually loading these fonts, right?
Okay, so if I remember correctly, we are doing something that we really should not be doing. Yes, we are loading a local font using a link in the head.
Okay.
And also, this is a Google font. So
we could
have
use
this improvement. Yeah.
We could use our Next.js library, and because right now when we load the image like this, it could affect flash of unstyled text. There's some fancy term in these cases that we actually before these fonts are loaded, and we can see that original text, for example, for our system or other, and we could have this, and it also can, when the font finally loads, it could change the layout, right? So as you already import the barrier from the Next font Google.
Yeah, so we have the Next font library, right? But then we have also the Google version of this. So every font available on Google Fonts is available also here. So we'll use this to host the font locally, but this will be optimized by Next.js.
Okay, so
we use it like that exactly. This is this cursor in action. It's very nice. So we are setting up the font with the variable, and then we'll use it in the body class name.
We can delete the link, right?
Yes, for sure. So we don't really need the head anymore. Pretty nice. Okay, let me refresh again. Oh, we have seen the blur effect now.
Great. It looks so much better.
So nice user experience. Yes, I like that. It's so much better than blank space. So let's see, analyze page load. No, this is already flying. The loading speeds are much better.
Yeah, and also like the overall, the page is so much smoother than with the skeletons, with the blur, etc.
Yes. So we are not seeing the font anymore here. Only the CSS.
CLS.
The CLS. It's sitting around 0.03. So still, around
this is a good
ballpark.
score for this.
Nice. Yeah, because this is still on green all the time. LCP at 0.6, SAP at 0.3. This is not something that we are focusing on, but it's worth to always
everything
include
is green. We are 100% green, I believe. And
yes.
Right now, I think there's one more important thing, right?
Yeah, we are still
that we're talking about.
Yes, so we are still sitting on the INP score of 1.5 seconds.
Yeah,
Jacob,
that's terrible. I would say we need to definitely change it, fix it. But how we can do it actually, because there are probably some important functions that need to be run.
Yes,
needs to be executed, and yeah.
So this is happening in the discount button that I have here. We're already seeing this synchronous function. There's this event handler. So this is running some parsing of the discount, is doing some analytics, and this is all synchronous. For some reason, we don't have async API for this. So what's happening here? Like we can explain first, and then tell you how to fix it. It's happening because we are blocking a main thread in this event handler, so the browser can't do any other important work like rendering the the content, rendering the next frame, as I said before. So it's lagging, and this is not an experience that the user wants to see. Yes, because there could be some dead clicks or something, or the user can get frustrated. So we have to some way, we have to find a way to tell the browser that, okay, this is not as important. Maybe you can take on the next task in your queue. Like, the next task could be rendering the animation or rendering the new element. And we can do it with this new API, actually, this new scheduler yield API that is not yet available, on every browser, on every it's not available on Firefox, I believe, on Safari, but we have it on Chromium. So what this is doing, it's let me make this async, and don't worry about the TypeScript error for now, because it's not yet a common API. So we are leaving a hole for the browser. Like at this point, we are telling the browser, okay, you can pause with this event handler, take on the next task, and continue from this point forward. So we are basically making chunks of these calls and letting the browser step in between them.
Okay, that sounds very interesting. I can't wait to see it in the action, actually, because as you said, it should like display this drawer and then run these two functions again.
Yes. So we have this banner, and I'm clicking this now. 48 milliseconds measured.
I can actually see that after the click it appears, right? So it's visibly improved.
This is what the user wants to see, right? Like I click, there is an action, I need a reaction. I need to see something. So we are at INP 48, which makes everything green. But since this API is not available for now in every browser out there, there is also these other ways, right?
We can actually use to have an actual and the same effect. And we could use the set timeout to 0, for example, or even use the web workers in order to take this script and run it in other threads. So yeah, I think everything is green now, actually. We did a great job with fixing all of this.
So this is something, we still have the data and we are testing locally. Obviously, you would deploy this app and test with other services and also wait for the real user score. But we had a problem also locally. So now we fixed, everything we needed to fix. So this
is very important to like measure the real users data, because like you could have an effect, it works for me. So in your machine, when you're testing it locally, everything could be green, but for the real users with devices, it could be so much worse. So make sure to have to use for example, Versal Speed Insights to check the real users metrics data. So yeah, I think that's pretty much it.
This is it covered. So if you guys have any questions about the INP, CLS, or LCP, feel free to ask them now, since we have a small Q&A session now.
I hope it was very helpful for you guys, and right now you understand more about the core vitals and their metrics.
So while we are waiting for the questions to come in, maybe Jacob, you can say something about the ebook that we provide for you guys for free.
Yeah, of course. Make sure to check the ebook because it's like there is a lot of knowledge and it's packed with expert insights and real world examples. So make sure to download it, use the QR code from here, or check
it's right where there, I believe.
Yeah, or in the comments. You should also find the link in a comment, also for our blog articles. And make sure to check also our videos with the optimization tips and also the podcast. So
yes, and also feel free to check our socials: LinkedIn, Twitter, or X, I think now.
And yeah, subscribe this channel for
Yes.
sure, also.
For sure, and like this video.
So if there's no questions today, thank you guys for watching, and see ya.